Okay guys, today we're going to work on some power rules for exponents. They look like this. That is the power rule exactly. I'll explain how that works in a little bit. This is the power of a product rule. Sometimes there's a couple of things inside the parentheses. And the power of a fraction rule, which is also something we're going to learn today. I got a lot of examples here, so I don't know how long this is going to take, so just stay with me and hopefully it'll be very clear shortly. What I want to do is expand it first. So if I have a quantity like x to the third to the second power, I'm going to want everybody to expand that. That is x to the third to the second power. And then if we go back to our multiplication rule, or a product rule, we remember all we have to do is add the exponents and we get x to the sixth power. That's going to be pretty simple for us as long as this exponent isn't 99 or something like that. Expanding that would be really long, but that's to the third power. So we'll do y to the fourth times y to the fourth times y to the fourth. And again, following our product rule, we just add these together because the bases are the same. 4 plus 4 plus 4 is 12. And that is quite doable for everybody in the classroom, I believe. Same thing here. I'm going to expand as my strategy at first. And hopefully you'll discover something really quickly. M to the fifth times m to the fifth times m to the fifth times m to the fifth. That would be m to the fifth to the fourth power. 5, 10, 15, 20. So it's m to the 20th. I hope you're noticing a pattern here. And I'll explain that a little further and show you what to do on your tests and all that kind of stuff shortly. So again, I still want to expand on this page, just to show you a few more examples. Our bases are numbers this time, numerals. 2 to the third power times 2 to the third power. Our base is 2, our exponent 3. We add those exponents, and we have 2 to the sixth power. I'm going to do a quick experiment with this one. I want to make sure that's right. So if I follow my order of operations, I solve what's in the parentheses first, right? 2 to the third power is 2 times 2 times 2, which is 8. And 8 squared is 64. Hope you all agree with that. I want to know if this is also 64. If it is, I know that this answer is right. So 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Pretty cool. Okay, so again, I just want to keep following the same strategy of expanding for right now, but hopefully you're noticing something. This is 3 to the fourth times 3 to the fourth times 3 to the fourth, and our base is 3. Our exponents we add for the product rule for 8, 12. That is right on the test. I think everybody will do quite well on that one. 10 to the fifth, big number, 100,000 I believe, and 10 to the fifth, that's 2 of them, 3 of them, 4 of them. Expand it out. I'm sorry, bumping the tripod there. Oops, that's supposed to be a 5. Of course, so 10 to the fifth to the fourth power looks like that. Again, product rule, 5, 10, 15, 20. 10 to the 20th power. Good size number right there. Alright, let's look at a few more examples, but this time I want to, hopefully you've noticed, back here, 5 times 4 is 20. 4 times 3 is 12. 3 times 2 is 6. It's a little different than the product rule. If you expand it, you use the product rule and add the exponents, but the power rule allows us to just multiply those numbers, so it might be even easier for most of you. X to the fifth to the seventh power is equals x to the 5 times 7, which is x to the 35th power. Get the hang of that. This stuff's going to be pretty simple for you. Same thing here. This is n to the 6 times 6, which equals n to the 36th power. This one, our base is 5 to the 7 times 8, which is 5 to the 56th power. Another real big number, but that doesn't matter. That's how it works. And I think everybody can do that. Again, I want to expand here. It looks a little bit different. There's extra variables and stuff. So let's try expanding first on these ones. So I'm going to do xy squared times xy squared times xy squared. Now I look at my bases, and I think we talked about this before too. That's x to the first power. That's x to the first power. That's x to the first power. 1 plus 1 plus 1 is x to the third power. X times x times x is x to the third power. Y squared times y squared times y squared. Always looking for those like bases. 2, 4, 6. Again, I'm confident most of you can learn that pretty quickly. Let's try that again here. We'll expand. M squared n squared times m squared n squared times m squared n squared. Look at my like bases. M, and m. 2, 4, 6. My n's. 2, 4, 6 also. Pretty simple stuff. Let's try it here. X, Y, Z. Again, no, there's a 1 on those guys. Times x, y, z. X times x, x squared. Y times y, y squared. Z times z, z squared. Our first test could be simple for those of you that really are paying attention. Okay. Now let's go back a couple pages real quick. Remember, we can, with the power rule, exponent taken to another exponent, you're allowed to just multiply those together. So you can expand, which is a perfectly good strategy. Anytime you want, you will arrive at the right answer. Or, get that rule, this will be x to the fourth times 4, y squared 2 times 4. If you can do 4 times 4 and 2 times 4, you'll get it right using the power rule. X to the 16th, y to the 8th. If you can multiply 3 times 2, you'll get m to the 6th. And if you can multiply 5 times 2, you'll get n to the 10th. I think most of you will like that. X to the third times 2 is x to the 6th. Y to the 5th times 2 is y to the 10th. And z to the 1, or the first power, times 2 is z squared. That's a 2. That's why I always put that line through my z's. My 2's sometimes look a lot like z's, and I don't want that at all. So I always just see a line through my z's every time. Don't want it to be confused with a deuce or a 2. Alright, and the last thing we got to learn is the power of a fraction. Same concept here, but I want to expand. I really want to start by expanding, just so you can see. Because hopefully you remember 5th, 6th, 7th grade when you're multiplying fractions. That's really all this is going to be. This will be 2/3 to the second, thirds times 2/3. And when we multiply fractions, we multiply numerator times numerator, denominator times denominator. 2 times 2 is 4, 3 times 3 is 9. Piece of cake. We're going to expand this also until we get real good at it, and then we won't have to expand, I don't think, but I like to start there. Again, numerator times numerator times numerator, 1 times 1 times 1. I don't think too many of you will ever get it wrong. 4 times 4 is 16 times 4. I won't show the math there, but I think you'll trust me that it's 64. And this one I might have to do a little bit of math on. I'm going to do 3/5 to the 4th power, expand it out. It'll look like this. And hopefully my brain's working well this morning. 3 times 3 is 9, times 3 is 27, times 3 is 81. And 5 times 5 is 25, times 5 is 125, times 5 is 625. You can double check me with a calculator if you want, but I'm pretty sure that's right. So this expanding strategy works really great for the power of a fraction. Let's do a couple more of those, but let's, I don't know if I can do 7 to the 4th power. Give me a chance here. I'm not going to expand this out. I'm going to do this in my head, because if I don't expand it out, I can do 2 to the 4th power in my numerator and 7 to the 4th power in the denominator. Compute those and we'll have the answer. So 2 to the 4th is 2, 4, 8, 16. And I may have to scratch this out. Let's see. 7 times 7 is 49. Times 7 is I want to say 289, but I better do this. 49 times 7, 60, oops, 63 and 28, 343 times 7 again, 21, 2, 28, 30, 3, 21, 24, 2,401. That's a tough one to do in your head. So when you can't do it in your head, you grab yourself a calculator or use this magical tool right here. Alright, 3 to the third power, 3, 9, 27. And as we discussed on the last page, I believe 4 to the third power is 64. 4 times 4 is 16, times 4 more is 64. And let's see if I can do this one. 3 times 3 times 3, we just decided was 27. 3 to the third power in your numerator. And 8 to the third power is 64 times 8. Let's see, 320. Close to that again. Let's do it anyway. 64 times 8. Last thing, 32. 3, 48, and 3 is 512. Something tells me that could be simplified a little bit further, but I'm going to leave it right there just to hope that you understand all those power rules. Watch often if you need it. Thank you for your attention.